Okay. So good evening, all of you. Welcome to the first live session of the NPTEL course, Multi-Core Computer Architecture. And we are expecting more candidates. In the meantime, since it is a recorded version, people can watch it later as well. So few tips for candidates who are serious about this course. This course starts from a very fun required over the weeks. It has been taken up to the next level from the fundamentals of computer architecture and slowly starting about the pipelining concepts, performance analysis, and then we go slightly to the advanced processors. So every week we have added carefully planned assignments for you to get a better grasp on the subject. And the detailed solution of assignments also would be posted once the deadline is over. So the best way to approach the course is seriously take up the assignments, go through the videos, and wherever there is a difficulty, if you are not able to handle by yourself, please post it in the forums. Our team will get back to you. Kindly go through the assignments also very carefully. Some of them are very easy question and some may be of slightly higher difficulty. So we will take it up then accordingly. And our discussion forums are very active if you post your queries. So some students have already posted some of their doubts. So we would be going to them one by one. And in the meantime, if there is any query, kindly post it in the chat window as well. So there is a student, so Murtuja. She's an engineer, project engineer. So her question is why immediate addressing mode is faster than register addressing mode. So in the case of an immediate addressing mode, we are mentioning the operand in the instruction itself. So move A, or add A, B, 2. The 2 is an immediate operand. So going and fetching 2, there is no further steps required. As and when you fetch the instruction, this 2 is also part of it. Whereas when you tell move A, B, C, I have to go to the register file to bring B to bring C. So accessing this register file will take more time. So when you compare with an immediate instruction as well as a register instruction involves operations to be done by bringing the operand from the register. So first I fetch the instruction. After decoding, I come to know it is a register. That is an operand. Go to both the registers, let us say B and C, and then bring the content. So that will take some additional time of the operand fetch. Whereas if it is going to be an immediate addressing mode, then one of the operand is already available part of the instruction the moment fetching is over. So immediate addressing mode, in that way, it's going to be faster. So all those who joined late, what I was discussing is how immediate addressing mode instruction is faster than register addressing mode. Now let me go to the question from Divya Swarup Gampalla. He was telling about increase in pipeline increases the throughput, but at the same time increase the latency. So that's true because we are adding pipeline registers in between different stages. So initially when it's a single monolithic unit which takes only 5 cycles, now I am dividing into one cycle 5 stages, but in between the stages we have to add a pipeline latch. So as far as a single instruction is concerned, when you go for pipelining, it will take slightly more latency. But what we are then interested is not about whether a single instruction takes more time or not. I collectively take it as a program, and program consists of multiple instructions. So these multiple instructions are parallelly overlapped. Before the execution of one instruction is completely over, we are going to fetch the new one in a pipeline fashion. So because of this, we are in a position to overlap, and because of that, throughput will increase, and number of instructions completed per unit time will give an advantage how early a program overall can be completed. So rather than looking at one instruction, it will be always good to look at how much time it will take for the entire process to run. Now the second question from the same person is, in CPI calculation, we consider base CPI and stalled CPI, but we are not. Is there any possible justification? Correct. So when you take, let us say 10 instruction, the first instruction has some initial latency, and thereafter regularly at every cycle, one instruction is getting over. Ideally, in the case of a pipeline, we are not considering the initial latency, because what we are interested in is once the pipeline is fully operational, means all the stages are now active, what is happening. So when you execute a large program with many instructions, whatever extra latency happen in the initial one. For example, let us say I have 10,000 instructions. So first instruction will take 5 cycles. Thereafter, every cycle, one instruction is getting over. So we will take altogether 10,004 cycles. And the CPI is going to be 10,004 divided by 10,000. So ideally it is 1 because of the initial latency we are not considering. So it's been amortized. That is a justification. And then third question from the same person is, can you elaborate on out of order RISC-V instruction application and real-time examples? So RISC we started, and out of order superscalar processor is what you are going to learn in 3rd, 4th weeks. That will give you more clarity on the subject. So out of order processor really help in handling dependencies, in executing multiple threads. So these processors will give a CPI value as low as possible, number of cycles required per. And the RISC-V, the modern ISA, the RISC-V make use of the out of order set, the architecture. And we will talk about it in the subsequent weeks when we have cache and DRAM combination all used. And then we talk about how intensive memory bandwidth requirements need to be in order to satisfy the RISC-V instructions. So we will learn about the advanced features down the line. So I request the candidate to wait. So there is another query from Saurav Gatnekar. So students who are already joining in live, if you have any query, kindly post it in the chat box or in the forms that is being shared. I will be able to see that and get back. Now I am replying to those who have already filled it up. So the question from Saurabh is there any additional project as discussed in the first lecture? So we request you to work with a simulator called Gem5. It's an open source simulator. You install Gem5 and then you contact in the discussion forum. Maybe after three weeks or so, we will give a brief guideline about how can you work with Gem5 in order to mimic basic processor features. So till then, you please hold on. But what you need to do is getting a familiarity with an open source simulator, and additional projects we can build depending upon how fast you are able to work with this. There are some questions generically for preparation. How can we improve our studies by Suraj Kumar Singh? How can we boost our skills? So that I'll get back to you at the end. There is a question from Abhishek Kumar Dubey. While completing this course, what benefits should get later on? So this course will give a complete overview about the internals and the working principles of modern multi-core processors. We look from the processor aspect, we look from the cache aspect, and from the interconnect aspect. So you have a total understanding from the processing side, how core works, from the memory side, how cache memory, main memory, and the disk, the hierarchy of memory works, and the intercore communication. And we have 1 or 2 lectures in talking about application mapping, accelerators, and advanced networks. So this will give you an idea of how a state-of-art microprocessor looks like. And that's exactly what an industry wants. If you're looking forward to work in industry, where the focus is more on design of multi-core processors, this knowledge is obviously going to help. I hope I answered Abhishek Kumar's question. So now there are questions from Nitin Chaturvedi, from Suraj Kumar Singh and all. How can you improve upon the course? How can you get better learning from this? So all what I am telling is consider these courses, NPTEL courses, as an opportunity to learn about Okay, sorry for the interruption. There was a network glitch. I hope I am back live now. Can someone clarify? Can you hear me now?
Yes, sir, you are audible.
Okay. So I was talking about this question about how to work forward. So consider NPTEL courses as opportunities by which you would be in a position to learn about advanced topics so that the industry expectation about your understanding of what is happening from the fundamental level to the advanced level is really going to be helpful. So these are the questions that we have already. And NPTEL is a very good option for students to work with the learnings of the faculty members from premier institutes and try to take as many NPTEL courses as possible and seriously work on the weekly assignments. Don't look at only the end course. If you are not studying on a regular basis, then it won't add much of a learning. So every week, spend some time going through the video, solve assignments, and then wherever you find difficulty, contact in the discussion forum and wait for detailed solution of assignment. And that's good enough for carrying forward. There's a question from Gautam Mandal, PhD research scholar, how to run multiprocessor in ChamSim. So one thing is I'm not familiar with ChamSim as a simulator. So you may look at, so our research group at IIT Guwahati work with the GEM5. So we only know about the internals and the working principles of GEM5. I request you to log into manuals available or people who have already publishing their results with the ChamSim. And that way you will be able to get forward. So that's answer to Gautam Mandal who asked the question about ChamSim. So these are the questions that we have as of now. If there are any specific questions, we would be very happy. Sunny Kumar, Sunny, you can unmute and speak. Sunny Kumar is there. You can unmute, please. You can chat also in the chat window of the Teams. In the meantime, if any other candidate wanted to speak, clarify any query, I am open. Please raise your hand or unmute and speak. So I request there are very few candidates. It would be good for me to know about the background of the candidates. If people can unmute and speak, are they student and how they feel about the course initially. That's a way how you can interact with me. So Sai Tanuja, can I know your background? If you can unmute and speak, I will be able to know more about you. Are you a student or faculty or from industry? Over to Sai Tanuja. Sai is not speaking. So I go to Brinda Chauhan. Brinda, do you wish to speak? Can you introduce yourself?
Yes, sir.
Yeah, please go ahead.
I'm from PES University.
Okay.
I'm in my final year of doing my BTech for Electronics and Communication Engineering. Okay. And I had computer architecture as a compulsory course in semester 6 last sem.
Okay.
And I really enjoyed the course that we had in college. So I just wanted to see the course structure that was introduced in IITs and what's taught there and how it compares to it. So till now, I have been enjoying the assignments that have been there. They're very similar to what was in my college as well.
Did you learn anything new, to Brinda, or it's still a refreshing portion? Did you complete?
I have reached week 4, and till now it has been the same as my previous semester itself.
Um, I'm so sorry. We have a severe network problem at IIT Guwahati today. I don't know. So I request Brinda to continue what she told. I just was asking how is overall the course? Are you learning anything new, or it's only a refreshing of what you learned in the last semester?
So till now, it has been a refreshing course itself. And I'm hoping moving forward, I can learn something new. Previously, I have designed a project on a single cycle RISC-V architecture on system Verilog. So that made me feel that I do have some sort of interest in moving towards understanding architecture even better. So
Okay, we do have options of students able to do projects with us. If you are really able to enjoy the course, maybe after 1 month, you can approach us for a joint project if interested.
Sure, sir. And how do I do that?
Yeah, you can write to me maybe after 4 weeks of assignment is over with an assignment mark also. And slowly try to work with Gem5 as a simulator. And we will be able to give the background support that is required. There are some students from, this is PES is from Bangalore, right?
Yes, sir.
Yeah. There are some students previously who worked with me, maybe 3 or 4 years before. They did an internship with me. It's pre-COVID time.
Okay.
Yeah, you can contact us, and then if interested, we will be able to support students who wanted to explore this field in terms of joint projects, or your final year BTech projects can be done jointly. We give you some internship opportunity for students to come here.
Sure, sir.
Okay.
Yes.
Let me try to hear from others.
Hello, sir. This is Samarth. Yeah, this is Samarth Golwalkar. I have registered for your course. Like even I had started like watching it even before it was live, like in the archives. I liked it like in the NPTEL archives. Sir, I am actually a professional. I work in automotive software, and I wanted to explore this. I have been doing some projects of my own, like single cycle processor is the most common one, which I have done recently, and done on and also emulated on the FPGA. It is not working quite the thing. Some errors are still there, but I'm still doing it. And apart from that, I'm enjoying your course. I'm still at the week 2 only. Like I have missed few of the deadlines as well, but I will complete till week 4 soon enough in this long weekend that is coming. So I will continue watching it and learning more from it, because my background was in electronics and telecommunication. We didn't really have these subjects in my college. So that's why I'm learning it through this new thing. Yes.
That's great, Samar, to know that even so you completed your engineering and then you are in automotive.
Yes.
Electronics.
Yeah, I'm working with KPIT now. Like right now, and spin-off they have created with that. I'm working in embedded software kind of a thing. So let's see. I mean, I wanted to learn this, and I have to like. I'm interested in joining the full time this learning about this architecture and designing computers, but I first need to check whether really my interest is there or not. So that's why I joined this course.
Yeah, great. That's good. That I request you to continue it without breaking the deadlines, and every week set apart some time. Once you are very sincere for 2 months, you will have a complete picture of what internals of processor is, such that any new processor coming to market, all the terminologies would be familiar. Only thing, some numbers, sizes, speed, everything would vary. And there is a lot of promising options in India, especially with to Gujarat and in Guwahati semiconductor plants is coming. We require a lot of people in the design, a lot of people in testing and verification and all. So people with architecture background would be very good in the design. And if may or may not know the Verilog background, but people who are able to appreciate systems from a processor, from a memory point of view, will be of huge demand in the next few years in India. That's what our connections with premium companies are telling. What are the kind of skill set that you are looking forward for the next 1 or 2 years? Huge potential. Wish you all the best.
Thank you. Sir, one more question. Like you just told another student that you would be doing some projects like
yes,
in remotely. Can I be also a part of it? Like just Like
Yeah,
if I
we
can
will pull in
contribute.
students. See, one is I generally my team work in Gem 5. It is
Okay.
an open source architectural simulator. You can install
Yes.
Gem 5, and once it
Yes.
has been done, if you write an email, and we will be able to help you with some initial inputs. So you
Yes.
will get some hands-on experience also on working with codes, which will mimic a processor, the pipeline, all other
Yes.
aspect. Okay,
Yes. Thank you, sir.
thank you.
Yes. Thank you.
Over to the next. Can we have Gautam Mandal? Would you like to speak? Okay, if seems Gautam is busy, I'll tell about the Muhammad Sams Tabraj.
Good evening, sir.
Good evening. Good evening. Please
Sir,
introduce yourself from where are you, and then please share your concerns, experience.
I'm a final year student and I'm doing BTech in Electronics and Telecommunication Engineering from Veer Surendra Sai University of Technology, Odisha. And
Okay.
currently, sir, I am building my career more focused on VLSI part. And I have already done some couple of projects on RTL design of hardware accelerator. And I really want to explore the field of computer architecture so that it can help me further in this journey.
Great. That's great to know, Muhammad Sams. And then, so VHDL or Verilog background will be helpful in design, and then this will really give you an idea of how processor overall works. You can work with pipeline, writing Verilog code or VHDL code for pipelines, hazard management circuit, branch predictors. These are of extreme demand, and such small projects, keeping it in GitHub and then adding it in your CV will add value, because when you look from a conventional college point of view, these are things that are not being done in depth. Only a mild level of shallow coverage would be there, but students with interest like this can explore. It's good to hear that you are trying to explore this field. Great.
Yes, sir.
Okay. So, Sai Tanuja, would you like to speak? So, Varalakshmi. So, Vatsal, it seems to Varalakshmi.
Hello, sir.
Good evening.
Sir, I'm in a 4th year and I'll be graduating in the next month. Currently, I'm working in a company named Dept. It deals with in automotive sector. So,
Okay.
I moved a project in my college related to CNN accelerator for digit recognition. Over there, we made the whole the Python code was different, and then we imported all the Python libraries to the AMD software where we converted it to the Verilog code. Over there, we were trying to optimize the power issues over there. So, like, it was a kind of chip designing only, but like we were doing everything from scratch. So we are not having a lot of knowledge. So will this course help me to design the architecture and modify my design so that I can reduce my power consumption over there as well?
Okay, Vatsal. So thank you for sharing you what are you doing. This course may not directly help you in terms of what you do as far as the current project that you are talking, but you get to know especially about how memory is being organized, what is the hierarchy of memory, what is the internal working of memory, and you get some idea of what is a prediction circuit. So branch prediction circuit is being used, or something similar is used in many prediction mechanisms, especially in neural networks when prediction is involved. Understanding of branch predictor and the state transitions will obviously help. So bits and pieces, different technologies used across will be helpful in architecture level learning and implementation of neural networks as well. Towards the end, we have a lecture. That's in the 12th week. We have a lecture on deep neural networks accelerators. That will give you what is the hardware of such accelerators, and then how can you work more forward to it. Okay.
So, sir, any more courses that I can enroll myself to get a better knowledge about things and learn about these things in a better way, apart from this multi-core computer architecture?
There can be GPU programming or accelerators. Any topic related to ML or AI accelerators will give a hardware perspective of AI applications.
Oh, okay, sir. And any projects that you are doing which I am able to join, sir?
For accelerators, if you really want, you can contact Professor Satyajit Das. He worked in accelerator design. He is from IIT Guwahati itself. You can write a mail to him and then tell that you are taking my NPTEL course. Any options that is available, we will be able to help out.
Sir, can you please send his email ID in the chat window? If that will be possible.
No,
sir.
You can find it out from the webpage of IIT Guwahati, my mail ID, as well as Professor Satyajit Das.
Thank you, sir. Thank you very much.
Okay. Thank you. So there is a question from Varalakshmi, who is a faculty at Anna University. She is working in VLSI testing related to security application. This course will give you an idea about processors and memory, and there is a small lecture on hardware accelerators. But knowing architecture and then you take a hardware accelerator NPTEL course, your knowledge level and fundamentals would be very, very clear. And implementation of 5-stage risk pipeline in hardware, it's possible using Verilog design or VHDL design. And then assemble it into PCB at least to the FPGA board level, it will be okay. The other one I have not tried, but there won't be any problem. It's not about assembling into PCB at FPGA level or ASIC level. This is okay. Anyone else wanted to speak? Sumukha?
Good afternoon. Good evening, sir.
Good evening.
Yeah, sir, myself Sumukha. I'm from Mysore, Karnataka. I'm currently a final year student pursuing Bachelor of Engineering in EC, Electronics and Communication Engineering. So, sir, this is I'm very interested in this field, computer architecture. I have been researching it for about past 2 years. So actually I have done projects on it. I have built an 8-bit and 16-bit microcontroller based on Newman architecture, one Newman architecture. Not using Verilog, not using FPGA, but I have built it using from discrete logic gates from scratch. So that is my hobby. I don't like actually building it from Verilog and all. So I like to design circuits using pure logic gates only. So I have done it, and I actually created my own instruction set, microarchitecture and all, and I have documented it, and I have run very sample programs like Fibonacci, calculating of Fibonacci number, and displaying contents to a display, characters, alphanumeric characters on top, and then I have also implemented certain interrupt systems and all these. So this is my passion. Like, I want to get into computer architecture, and I also taken various courses on it. Other than this, I have also taken a course on this, which was offered by Princeton University in Coursera. So yeah, this is my passion.
How do you find this course till now? How do you find this course? Is it value adding to whatever you know and whatever you wanted?
Definitely, it's fantastic, sir.
Okay, good to know.
Definitely, yeah, it is very good. Actually, it's a very good course. That's why I took it. Actually, they made it compulsory in our college to take it. In final year, we have to take any one course from NPTEL. They have made that compulsory. But I actually got your course 1 year before only. I got to know about it. So it's a very beautiful course, sir. I am in week 4 currently. I also finished week 4. So I'm really looking forward to it in the future.
Great, Sumukha. And if any plans for the higher studies after that, please do consider joining in IITs.
Okay.
If at all you have any plans. Okay.
Sir, but I like to. I want to work with you as an intern for any kind of projects related to this, sir.
Yeah, we have only offline then internship. Once the course is over, you contact us. Okay.
Okay, sir. Definitely.
Thank you. Thank you, Sumukha. It's good to know that you are doing lot many project works related to this from the gate level.
Yes.
We go to Bul Chandra Garai. Would you like to speak?
Sir, I'm a PhD student at IISc.
Okay.
And I am working in high performance computing with Professor Govindarajan and Professor Sumit Kumar Mandal.
Okay. So both are my friends. Professor Govindarajan is my teacher. Yeah. Sumit is my close friend. Good to know.
And I work in Gem 5 lot.
Okay.
Till now, I was working in single processor only. Now, we did some, actually I work in ISRO also. So, so this means I am trying to make one processor for our spacecraft application. So through GEM5, I have implemented some small systolic array accelerator and trigonometric, because our spacecraft application, we use lots of trigonometric operation. So in a RISC-V processor, I have integrated these two accelerators. Now I want to extend this project to multi-core environment. So for that, I'm working right now. I'm preparing for my comprehensive exam.
Okay. It's good to see scientists from ISRO also are taking this course, and then I wish you all the best. Maybe in the subsequent months we can be in close touch. Please do well in your PhD, and then learn something from this course as well, so that your hardware background is strengthened.
Yeah, actually, last before joining my PhD, I did use one more course, that advanced computer architecture course. I liked it very much. It was very, very helpful for me to crack the interview, all these things in the IISc. So,
okay, that's very happy to hear. Some of my past course was helpful for someone in their career aspirations. Very good.
Yes.
Thanks.
Thank you, sir.
Okay. Is there anyone else? Did I miss? Somebody's watching from YouTube. That's still fine. Okay. So Ala Chenjaya, would you like to speak about your background? Who are you? How is the course going? Ala Chenjaya.
Hi, sir. Hi, sir.
Yeah.
Good evening.
Good evening.
My name is Chenjaya. I completed masters from IIT Gauti in VLSI. I worked under Sheikh Rafi Ahmad. So currently I'm working as a NOC design engineer in Qualcomm.
Oh,
so
you are in Qualcomm.
Yeah.
No. Okay.
Yeah. So currently I'm in NOC team in Qualcomm. So
okay, there in the NOC team you are working. Okay, great. Okay.
Yeah,
so
yeah.
I am also part of some of the work done by Qualcomm in NOCs. Okay.
I think Akshay, Akshay.
Yes.
He took internship from you, I think.
Yes, correct. He did an internship with me, correct.
Yeah, he and me same team only.
Same team.
We'll sit
He's also in the NOC design.
Yeah, he's NOC design. And many times I saw in campus, I heard about you. Usually you come to final project evaluation.
Yes.
MTech. So now I want to design NOC. So I want to start from basics. So I heard about you, how you teaching this NOC. So that's why I'm interested to take this course.
Very good, Chenjay. It's good to know students from IIT Guwahati are also doing well in Qualcomm. And then since the topic of NOC is very close to my research group, it's very happy to hear that. You look at the last few weeks videos, you can be able to understand NOCs, and a lot of publications we have done from our research group. We have now started with the quantum interconnect also.
Yeah, sure.
Hopefully, the research that we do, you may be able to find something that interesting. You can apply some of the concepts in the NOC design.
Yeah. Actually, I joined for the NOC concepts.
Okay, very good. Thank you.
Thank you. Thank you, sir.
Okay. So some question by Brinda. Let me see. So Brinda wanted to know, could you shed some light on higher studies opportunities that are present in IITs and IITs for computer architecture and high performance computing? So after BTech, students can directly join for an MTech PhD dual degree program. So you can either do for a direct PhD or an MTech plus PhD, 5 years, 37,000 rupees is the fellowship. GATE is mandatory if you are directly coming after BTech, a valid GATE score. If you come after an MTech, then GATE is not mandatory. You can write a departmental test also. We do have a screening test at IITs and NITs, followed by an interview. So having a GATE score, if at all they are BTech candidates with above CPI of 8, CGPA of 8 is generally preferred. And Almost all IITs, let's say Madras has a strong architecture group, Bombay has few, Kanpur, Delhi, Kharagpur, then Guwahati, then Hyderabad also has a good computer architecture team. So almost all the top 7-8 IITs have good computer architecture and high performance computing group in computer science department, and a very good VLSI group in the electronics department. Few NITs have also computer architecture, even though not many. But this is a very exciting area. Down the line, when India is going to become a semiconductor hub, we will be able to capitalize on it if we have industry-ready manpower who understands computer architecture well. Okay, it's good. And if Brinda, you wanted to know more about how to get into IIT Guwahati, please do contact us, or you can contact my PhD scholars. They will be able to help.
Sure, sir. Thank you.
So regarding Shakti processor is a product that is being developed as part of India's microprocessor development program. And Shakti is one of them that is developed from IIT Madras. So when I was a student, it's Professor Kamakodi, the current director of IIT Madras, and his team did the complete design layout. So it's one of the indigenous microprocessor India made, that's Shakti. The other one is Vega, that's by CDAC Trivandrum. And now the out of order versions, the advanced versions of this processor are also in pipeline. Soon that will also come to the market. It's good that some of you know already about Shakti. Please go through Shakti processor or Vega processor webpage and try to understand what are the indigenous microprocessor development that has been happening in India. Thank you, Sumukha, for bringing that topic of Shakti. But IIT Guwahati is not involved. I learned a lot from Shakti processor design when I was a PhD scholar at IIT Madras. Okay. So I see there are no more questions. Then I think we will wind up the session. Just a summary for students who are seriously taking this course. Take the assignments very carefully. A lot of these assignment questions should be repeated for final exam. Every week spending 2 to 3 hours of serious going through this. And there are some tutorial sessions also, where certain video lectures are exclusively specified for handling problems and design questions. That will also give you a good understanding about the lecture topics that has been covered. So don't miss the tutorials, don't miss the assignments, don't wait for the last moment for Wednesday to come. Solve it on the weekends itself, and that is good enough for you to score more than 80%. Many assignment questions or concepts similar in the assignment questions would be repeated. Okay, so thank you for all those who are joined. Please do join the next live sessions also. Watch us, and if there is any query, please do post it in the forms. And thanks to my backend team. So it's Elena, so Rajeshwari and Shubham, all the three of you, special thanks. All of you who are helping me in running this course. And many PhD scholars who graduated from my team already put in a lot of effort in making sure this course is reaching out to the length and breadth of country. Thank you to the CET team of IIT Guwahati who is supporting this. And wish you all the best. Have a productive learning. Enjoy computer architecture, the joy of learning architecture. Thank you and good evening.